Drawing kitchen electrical plan. One of the most common kitchen layouts will be shown as an example for basic kitchen wiring. To apply for a permit for electrical installation in a kitchen, an electrical installation plan must be provided in the kitchen sketch. To draw an electrical plan, you need to know the commonly used symbols on electrical plans and the NEC requirements. Symbols commonly used on electrical plans that need to be known to draw a plan. Receptacle. Dedicated receptacle. GFCI receptacle. Single pole switch. Three-way switch. Recessed light outlet. Pendant light outlet. Surface mount light outlet. The electrical plan will be drawn for this example kitchen. The cabinet layout is converted into the countertop view with appliance location shown. The electrical plan for this kitchen has been prepared in accordance with 2020 NEC requirements and can be submitted to the building authority for approval. Once you have obtained the electrical permit, you can start wiring the kitchen. Measurement of the room and marking of receptacles, switches and the location of lighting outlets. Mark on the walls, wall plates or floor width of the kitchen cabinets from the cabinet layout drawn for this kitchen starting from the corner. 36 inches plus 1/2 inch drywall for B36-36 cabinet. Next 12 inches for B12 cabinet. And the next one, until all the widths of the cabinets are marked on the wall. End of kitchen cabinets. Mark in the same way other wall. The kitchen cabinet end is known so the location for general purpose receptacles can be marked. Marking the location of the general purpose receptacle outlets. Measure the room and pre-mark the location of the receptacle outlets, according to the previously described code requirements. If necessary, adjust the distance of the receptacle outlets, install more outlets, but do not increase the distances described in the codebook. Measure the distance from the floor, and mark the bottom of the box on the previously pre-marked stud for placing the receptacle outlet junction box. 14 inches is the most common distance from the floor to the bottom of the receptacle outlet box. "14 inches from the floor to the bottom of the receptacle outlet box." Repeat marking for other receptacle outlet boxes. For countertop receptacles, the distance from the end or any opening therein to the receptacle cannot be greater than 2 feet. The distance between receptacles cannot be greater than 4 feet. For countertop receptacles, the junction box height is 44 inches from the floor to the bottom of the junction box, similar to switch junction boxes. Measure the distance from the floor and mark the bottom of the box on the previously pre-marked stud for placing the receptacle junction box. Repeat this for all other countertop receptacles and switches. Mark the switches' locations. Standard switch height is 44 inches from the floor to the bottom of the junction box. Measure the distance from the floor and mark the bottom of the box on the previously pre-marked stud for placing the switch junction box. "44 inches from the floor to the bottom of the switch outlet box." Measure and mark the location of the lighting fixtures on the ceiling. pendant light fixture, center of a small table. Surface-mounted light fixture above the center of the sink. Recessed light fixtures in selected locations. Installation of junction boxes. There are many different junction boxes available to suit the installations described above. 4 types of junction boxes were selected that are best suited for the kitchen rough-in wiring. A non-metallic, nailed Carlin 22.5 cubic inches junction box was selected for the receptacles and switches. For the light outlet junction box above the sink, a metal 4-inch octagonal junction box with an adjustable hanger was selected. A PVC commercial electric 12 cubic inches junction box rated to support fans was selected as the light outlet junction box above the table. For 2 switches, a Carlin 34.6 cubic inches non-metallic nailed 2-gang junction box was selected. 1-gang Carlin 22.5 cubic inches junction box. A single-gang Carlin 22.5 cubic inches or similar junction box can be used as the junction box for receptacle and switch. Front view of a single-gang Carlin junction box. Side view of a single-gang Carlin junction box. Details of non-metallic, nail-on single-gang junction box. This box requires a wall depth of at least 3 inches. The cable entering this Carlin junction box must be attached to a stud within 12 inches of the box. Box size, volume in cubic inches 22.5 cubic inches. The maximum number and size of wires that can fit in a box, making it easy to calculate. Each insulated wire counts as 1. 4 uninsulated bare wires as 1 and each additional as 1/4. Each device, receptacle, switch, etc. as 2. Example, the number 11/14 on the box indicates that the junction box holds 11 of 14 AWG, American wire gauge, size wires. Example of counting for 3 cables 14. 2 nm, Romex. 3 white and 3 black wires 3 plus 3 equals 6. 3 bare ground wires as 1. 1 receptacle, switch, etc. to be installed as 2. Total equals 9. This means the box can fit 1 more 14. 2 nm cable to get maximum allowable capacity. This means that the box holds a total of 4 14, 2 nm cables and 1 device. Knockouts for the cable entry in the junction box. Nails for mounting the junction box. 1/2 inch mark for standard house walls sheetrock thickness, 1/2 inch thick sheetrock. Markings for different wall finish thicknesses. Mounting holes for electrical devices. To install a nailed junction box, hold the junction box on the side of the stud and align the bottom of the box with a marking sign on the stud. While holding the junction box at side of the stud, drive the nails of the box into the stud. When attaching the junction box to the stud, the marking on the box for 1/2 inch sheetrock must evenly touch the stud. After marking the location for the receptacle, attach the receptacle junction box to the stud. Install 1-gang junction boxes for countertop receptacles and single switches as well. Receptacle or switch junction box installed. If necessary, add a piece of wood to move the junction box further away from any wall element, door trim, wall corner, etc., to make enough space for wall plate installation. Vapor-tight junction boxes for external walls may be required to meet energy code requirements. 2-gang Carlin 34.6 cubic inches junction box. Details of non-metallic, nail-on 2-gang junction box. Box size, volume in cubic inches 34.6 cubic inches. The maximum number and size of wires that can fit in a junction box, making it easy to calculate. Each insulated wire counts as 1. 4 uninsulated bare wires as 1 and each additional as 1/4. Each device, receptacle, switch, etc. as 2. Junction box clamps, push-in, 8 total. Junction box rails for inserting a divider plate between junction box gangs. 1/2 inch mark for standard house walls sheetrock thickness, 1/2 inch thick sheetrock. Nails for mounting the junction box. The nails can be switched to a different driving angle. Mounting holes for electrical devices. Install the junction box for 2 switches to the stud. Two-gang switch junction box installed. Commercial electric 12 cubic inches a non-metallic junction box, acceptable for fan installation. Commercial electric 12 cubic inches a non-metallic junction box acceptable for fan installation. Acceptable for fan support. Screw that secures the junction box to the joist. Screws securing the fan or lighting fixture, direct mounting to the joist. Button-type cable connector. Holes in the junction box for screws mounting the light fixture. Cable knockouts. Junction box cover. Install the light outlet junction box for the pendant light fixture above the table. A junction box suitable for the fan support must be installed in all locations where a paddle fan may be installed in accordance with Article 314.27 (c) of the 2020 NEC. Also, this junction box can support a heavy light fixture of the weight for which the junction box is listed. A ceiling light outlet junction box has been installed. 4 inches octagonal metal junction box. 4 inches octagonal metal junction box is used for the installation of ceiling or wall lighting fixture. Junction box capacity 15.5 cubic inches. Number of cables allowed in the junction box must be calculated in accordance with Article 314.16 2020 NEC. Ground screw hole with raised ground screw area. 1/2 inch, or 1/2 inch and 3/4 inch, knockouts, 8 total. Holes in the junction box for mounting it to the surface, 5 total. Junction box ears with screws for attaching the lighting fixture to the junction box. Adjustable junction box hanger. Adjustable metal junction box hanger. The adjustable junction box hanger is rated to support weight of 50 pounds on 16 inches span center. The bar clamp installs in the center 1/2 inch knockout at the bottom of the junction box. The bar hanger adjusts from 14.5 inch to 22.5 inch. Bar hanger clamp. Holes in the bar hanger support straps for the screws that attach the bar hanger to the studs. Bar hanger lock tab. Junction box installed to the adjustable bar hanger. Install the light outlet junction box for the surface mount light fixture above the sink. An example video showing the assembly of a 4 inches octagonal metal box with an adjustable rod hanger and the installation of this kit to the studs. Open the center knockout in the octagonal junction box. Remove the screw from the bar hanger slider. Place the junction box on the slider and loosely screw in the previously removed screw. Install the bar hanger with junction box between the studs. Adjust the junction box on the slider in the desired location and tighten the slider screw. Install the grounding screw. Above sink light outlet junction box has been installed. Recessed light housing installation. Recessed light fixtures. Recessed light housing for new construction. Recessed light housing for remodel installation. Canless recessed light fixture. Recessed lighting housing, new construction, will be installed during rough-in wiring. When installing a recessed lighting remodel housing, old work, or installing a canless recessed lighting fixture, the ceiling must be pre-wired during rough-in wiring. Install recessed light housings. To better show the installed electrical junction boxes, this electrical wiring plan will be converted to an electrical box layout view. Kitchen plan after conversion from an electrical plan to a view of the arrangement of electrical junction boxes. Description of the junction boxes. R. Receptacle. S. Switch. L. Light. The junction boxes for the microhood and the dishwasher receptacle will be installed after the kitchen cabinets are installed. All junction boxes and lighting fixture housings have been installed, except for the microhood and dishwasher. Cable installation. Drilling holes. Holes for routing cables through wall studs can be drilled at any horizontal stud height, but are typically located approximately 30 inches to 40 inches above the floor in each stud along the wall if needed. Side view, wider, of 2 by 4 inches stud and details of drilled holes. The drilled hole should be no larger than 7/8 inch, usual drill bit size, can be smaller but not less than ½ inch. The edge of the hole should be no closer than 1¼ inch from the edge of the stud. Drilled hole. 1/16 inch thick steel nail plate. If the edge of the hole is less than 1¼ inch from the edge of the stud, secure the hole with a 1/16 inch thick steel nail plate of the appropriate length. For holes greater than 7/8 inch in diameter, a steel plate must be used on both sides of the stud. Cable protection with a nail plate. If necessary, multiple holes can be drilled according to hole drilling rules. In wider studs, the hole may be larger. Any stud can be drilled or bored no more than 60% of the width of the stud. The hole is no closer than 5/8 inch from the edge of the stud, and the hole is not in the same section as a notch or cut. The cable must be protected by a steel plate if the edge of the hole is less than 1¼ inch from the edge of the stud. Stud in any external or load-bearing wall may be notched, but not deeper than 25% of the width of the stud. The cutout with the cable must be protected with a steel plate. The cutout must not be in the same place where the hole is drilled. For the top and bottom plates, the same drilling rules apply as for studs. The top plate of the stud wall. Holes may be drilled in joists no larger than 1/3 of joist width, and at least 2 inches from the top and bottom of the joist to the edge of the hole. For multiple holes, the distance between the holes must be 2 times the diameter of the larger hole. The hole can be drilled at least 1 inch from the end of the joists to the edge of the hole. Holes, openings in joists, beams. When routing cables through metal studs, a snap-in sleeve must be used in each stud. Installing cables. All cables must be installed and supported in a neat and professional manner so that the cable is not damaged during normal use of the building. Cables installed and run over beams, through studs and in horizontal chases are usually naturally supported. NM, non-metallic sheathed cables, Romex cable. Non-metallic sheathed, NM Romex, cable shall be supported and secured with staples, cable ties, straps, hangers or similar hardware and installed in such a way as not to damage the cable. Approved supports, listed, for NM cable: staples, cable stackers, cable ties, etc. Requirements for installation and support: NM non-metallic sheathed cable, Romex cable. The distance between the supports shall not exceed 4.5 feet. The support from the enclosures, outlet box, shall not exceed 12 inches. After the cable enters the junction box, the cable must be approximately 12 to 18 inches long after entering the junction box for splicing, cable connection. If staples are used as cable supports, the staples must be approved to support NM cables. The NM cable must be stapled on a flat surface, not on the edge. The NM cable must be stapled on a flat surface, not on the edge. Do not drive the staples too hard into the cables. Staples should be drive tight enough to hold the cable in place, but not so tight as to pinch and damage the cable. Driving the staple too hard can damage the cable. Do not drive the staple over the staple during the stapling another cable in same place. The staple must contact the cable with its flat surface, not a sharp edge. The cable must not be stapled closer than 1¼ inch from the edge of the stud. No more than 2 cables can be stapled with the same staple. Do not damage the cable when removing the staple. If it is not possible to staple the cable, too narrow space, a cable tie or other way of supporting the cable should be used. The low-voltage cable must not occupy the same cable hole as the power cable, it must be run in a separate drilled hole. Cable stackers. The edge of the cable stapled in the center of the 2 by 4 inches stud must be 1¼ inch from the edge of the stud. Otherwise use hangers, stackers, etc. to support this cable. If there are more than 2 cables running along a 2 by 4 inches stud, use cable stackers, etc. to keep the cables away from the stud. If the junction box does not have cable clamps or it is not possible to mount a cable clamp to the junction box, and the cable enters freely into the box knockout, the cable must be secured to the structure with staples or other means. In this case, the cable stacker does not support the cable at the entrance to the junction box to meet NEC, National Electrical Code, requirements. 7/8 hole for cable. Up to 3, 12 or 14 gauge, NM cables per drilled 7/8 inch hole in the 2 by 4 inch stud. Steel cable protection plate, nail plate. Use a nail plate to protect the cable if necessary. Installation of wiring in the kitchen based on the drawn plan. Cable routing. For kitchen electrical wiring. 14, 2, 12, 2, and 12. 3nm non-metallic sheathed Romex cable will be used. When installing cables, do not mix wire sizes in one circuit. According to the 2020 NEC, 14-gauge cable shall be protected by a 15-amp circuit breaker and 12-gauge cable shall be protected by a 20-amp circuit breaker unless the exceptions described in the code, for example, motor loads, are met. The 14, 2, and 12, 2nm cable contains the following wires: bare, ground wire; white, neutral wire; black, hot wire. The 14, 3nm cable contains the following wires: bare, ground wire; white, neutral wire; black, hot wire; red, hot wire. Cable installation for this kitchen. How many branch circuits? To meet NEC requirements and follow good electrical practices for house wiring, this kitchen requires 5 20-amp circuits and 1 15-amp circuit. 20-amp circuits will serve countertop receptacle, refrigerator with general-purpose receptacles, dishwasher and microhood. The 15-amp circuit will power all the lighting in the kitchen. The cables between the junction boxes on each circuit can be routed in any combination, but this wiring example will show the simplest cable routing method. Installation of branch circuits for the kitchen countertop. The number of receptacles serving the countertop will be divided into 2 circuits. Route all home run circuits cables from the panel board, power source location to the first junction box location. When installing cables, label the cables or cable ends so that they can be easily identified when connecting. The 3 receptacles on the sink side will be powered by one circuit, and the next 3 receptacles on the stove side will be powered by the other circuit. The receptacle for the gas range will also be powered from the same circuit. Install the first branch circuit for the countertop receptacles on the sink side using 12, 2nm cable. The cable feeder from the panel board can be routed to one of the 3 installed junction boxes. The receptacle to the left of the sink was selected as the first receptacle to which the branch circuit cable, home run, from the panel board would be run. Drill cable holes where needed and run 12, 2nm cable from the panel board to the first junction box of the first of 2 small appliance branch circuits. Route all home run circuits cables from the panel board, power source location to the first junction box location. When installing cables, label the cables or cable ends so that they can be easily identified when connecting. Run the same type of cable from the first junction box to the next, and then to the last. View of the wall with installed cables and junction boxes. Cables can be inserted into the junction box from the top, bottom, or top and bottom. First junction box. Cable from the panel board. Cable to the second junction box. Cables stapled to a stud no more than 12 inches from the cable entry into the junction box. After entering the junction box, the cables must be long enough to be spliced, connected, inside the box. The cable should be 12 to 18 inches long from the entrance to the junction box. second junction box. Cable from the first junction box. Cable to the third junction box. Cables stapled to a stud no more than 12 inches from the cable entry into the junction box. Third junction box. Cable from the second junction box. Cable stapled to a stud no more than 12 inches from the cable entry into the junction box. Install the second branch circuit for the countertop receptacles on the gas range side using 12 2nm cable. The cable feeder from the panel board can be routed to one of the 4 installed junction boxes. The receptacle to the left of the range was selected as the first receptacle to which the branch circuit cable, home run, from the panel board would be run. Run 12 2nm cable from the panel board to the first junction box of the second small appliance branch circuits. Run the same type of cable from the first junction box to the next receptacle junction box, which is for the receptacle that will power the gas cooktop, and to the next, and then to the last junction box of this branch circuit. View of the wall with installed cables and junction boxes. The cables are inserted into the junction boxes in the same way as in the previously described branch circuit 1 of the kitchen countertop. Install a 20 amps branch circuit for the refrigerator and general purpose receptacle. The cable feeder from the panel board can be routed to one of the 5 installed junction boxes. The refrigerator receptacle was selected as the first receptacle to which the branch circuit cable, home run, from the panel board would be run. Run 12 2nm cable from the panel board to the refrigerator receptacle junction box. Run the cable from the refrigerator receptacle junction box to one of the general purpose receptacle junction boxes, and to the next, and next, and then to the last junction box of this branch circuit. The cables are inserted into the junction boxes in the same way as in the previously described circuits. Install a 20 amps branch circuit for the microhood. The cable from the panel board is led to the place where the microhood is located and left in the expected place for the microhood receptacle, which receptacle, after installing the kitchen cabinet above the microhood, will be installed inside this kitchen cabinet. Install 12 2nm cable from the panel board to the microhood location. The cable for the microhood receptacle is left in the expected receptacle location. The cable must be long enough to reach the microhood receptacle junction box and allow for connection in it. Secure the cable properly to the building structure. Install a 20 amps branch circuit for the dishwasher. The cable from the panel board is run to the location where the dishwasher receptacle will be located, or the location of the dishwasher if directly wired. The dishwasher receptacle is usually located under the sink. Install 12 2nm cable from the panel board to the dishwasher receptacle location. The cable for the dishwasher receptacle is left in the expected receptacle location. The cable must be long enough to reach the dishwasher receptacle junction box and allow for connection in it. All the 20 amps circuit cables that serve the kitchen are already installed, and now the wiring for the lighting will be installed. The cable can be routed to any of the 3 switch junction boxes. And you can also route the cables between the switches and light outlets in various ways. This example shows one of these ways. The 2-gang switch junction box near the door was selected to run circuit cable, home run, from the panel board. Run the 14, 2 nm cable from the panel board to the 2-gang switch junction box. Install the same type of cable between the 2-gang switch junction box near the door and the switch junction box near the sink. Run 14, 3 nm cable between the 2-gang switch junction box near the door and the switch junction box near the wall opening that allows entry into the kitchen to create 3-way wiring for recessed light fixtures. Install a 14, 2 nm cable from the 2-gang switch junction box to the light outlet junction box above the table. Install 14, 2 nm cable from the switch junction box near the sink to the light outlet above the sink. Run 14, 2 nm cable between the switch junction box near the other kitchen entrance and the one of the recessed light fixture housing junction box. Run the cable from one recessed light fixture to the next until all light fixtures have cable. You can run the cable any other way between the light fixtures. Insert the cables of the lighting circuit into the junction boxes. 2-gang switch junction box. 4 cables inserted into the 2-gang junction box. Cable to the light outlet above the table. 14, 3 cable to the switch junction box at second entrance to kitchen. Cable from the panel board. Cable to the switch near the sink. Cable secured to a stud no more than 12 inches from the cable entry into the junction box. Nail the junction box appropriate to accommodate the wires and switches according to the junction box calculation, by NEC, National Electrical Code. Install the cable support, cable stacker. Insert wires into the junction box. Mark the cables if necessary. Light outlet junction box above the table. Cable inserted into the junction box of a light fixture installed above the table. Cable secured to a stud no more than 12 inches from the cable entry into the junction box. Switch junction box near the sink. The cables are inserted into the switch junction box near the sink. Cable to the light outlet above the sink. Cable from the 2-gang switch junction box near the door. Cable secured to a stud no more than 12 inches from the cable entry into the junction box. Light outlet junction box above the sink. Cable inserted into the junction box of a light fixture installed above the sink. Cable secured to a stud no more than 12 inches from the cable entry into the junction box. Select and open the junction box knockout. Install any approved cable connector. Insert the cable into the cable connector. Attach the cable to the stud within 12 inches from the cable entry to the junction box. Recessed light outlet housing. Installed cables for recessed light fixture. Cable from the switch. Cable to another recessed light fixture. Cables secured to a beam no more than 12 inches from the cable entry into the recessed light fixture junction box. Install the cable from the switch and cable to other recessed housing if more than one light fixture will be installed. Secure cables to the beam within 12 inches from the housing. Recessed light outlet housings. Installed cables for recessed light fixture. Cable from the recessed light fixture. Cable to another recessed light fixture. Cables secured to a beam no more than 12 inches from the cable entry into the recessed light fixture junction box. Recessed light outlet housing. Installed cable for recessed light fixture. Cable from the recessed light fixture. Cable secured to a beam no more than 12 inches from the cable entry into the recessed light fixture junction box. Switch junction box near the second entrance to the kitchen. 2 cables inserted into the junction box. Cable to the recessed light outlet. 14. 3 cable from the 2 gang switch junction box at the other entrance to the kitchen. Cables secured to a beam no more than 12 inches from the cable entry into the junction box. All cables are already installed. If necessary and where required, cables must be protected with nail plates. Cable splicing. The cables installed in the kitchen are ready to be spliced, connected. Before the rough-in inspection, the cables in the junction boxes must be spliced. Splicing is the joining of 2 or more separate wires, conductors. The grounding conductors must always be connected to each other to form one equipotential bonding. The wire nuts will be used as splicing connectors. All types of wire nuts are listed for a specific number of wires that can be spliced together with a specific type of wire nut. Any wire nut can be used to splice, connect, the ground wires, but a special green wire nut, ground connector, will be used in this example. The green wire nut has a hole on one end that is used to pull one of the bare wires through it, which will become a pigtail on the ground wires to the equipment ground terminals. When splicing the wire, it is enough to make 3 to 5 twists of the wire when the wire nut is tightly screwed on the wire. Do not twist the wire too much up to the cable sheath, as this may damage the insulation of other wires. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Twist the ground wires. Hold them in your fist. This gives you a minimum length of 6 inches from the box entrance, required, and cut the shorter wire at the front of your fist. Pull the long wire through the green wire nut hole and twist it clockwise. Neatly fold and push the spliced ground wires with the connector into the junction box, leaving the pigtail outside the junction box. When using a standard wire nut to connect the ground wires, add a pigtail that is needed to connect the ground wire to the electrical device. Separate the ground wires, bare, from the others and push the ground wires towards the back of the junction box. Hold the ground wires in your fist. This gives you a minimum length of 6 inches from the box entrance required, and cut them at the front of your fist. Take a piece of bare ground wire to make a pigtail and using pliers twist the wires together clockwise. Use a wire nut to secure the connection. Neatly fold and push the spliced ground wires with the connector into the junction box, leaving the wire nut pigtail outside the junction box. A medium-sized wire nut will be used for all other connections. This wire nut can also be used to connect ground wires. A better connection is obtained by twisting the wire with pliers before screwing the wire nut onto the twisted wires. Do not twist the insulated wires too tightly to avoid damaging the insulation. Separate the neutral, white, wires from the black ones. Fold and push the wires towards the back of the junction box. Hold them. Grab them and cut them in front of your fist. Take a piece of white wire to make the pigtail. Strip the end of that wire and also strip the ends of the white wires coming out of the junction box about 1/2 inch. Using pliers and a wire nut, connect the pigtail and other white wires together. Fold the spliced white wires with the connector and neatly push them into the junction box, leaving the pigtail outside the box. The sheath, jacket, of the cable should protrude beyond the entrance to the enclosure, electrical junction box, not less than 1/4 inch. Do not overfill junction boxes with cable with a cable sheath. The cable sheath not removed takes up space in the junction box that may be needed for splicing and device installation. To avoid electric shock and tripping of the circuit breaker, make sure that the insulation of the wires, conductors, is not damaged. Cut with a knife when removing the insulation from the wires. Cable conductors colors: bare copper, GE, ground wire, conductor. Ground wire may be green or green with yellow stripes in other cables. White, N, neutral wire, conductor. Black, H, hot, power, wire, conductor. Red, H, hot, power, wire, conductor. Splicing of the receptacle junction box with a cable from the power source, can be other receptacle outlet, and a cable to power another outlet, 2 cables. Splicing, connection sketch. Receptacle junction box with 2 cables inserted into it. Cable from the power source. Cable to another receptacle outlet junction box. Spliced, connected, wires. Strip the cable sheath. Cut the ground wires, bare, to no shorter than 6 inches. Take the same size ground wire for the pigtail and use a wire nut to splice them together. Insert the spliced wires with wire nut into the junction box. Trim all wires to the required length, no shorter than 6 inches, and insert them into the junction box. Splicing of the receptacle junction box with a cable from the power source, or other receptacle outlet, 1 cable. Splicing, connection sketch. Receptacle junction box with 1 cable inserted into it. Cable from the power source. Spliced, connected, wires. Remove the cable sheath, cut all wires to the required length, no shorter than 6 inches, and insert the wires into the junction box. Splicing of 2-gang switch junction box for 3-way and single pole switch with a cable from the power source, a cable to power another switch, a cable, 14.3, to a light outlet and a cable to a second switch to provide 3-way control of the second light outlet, 4 cables. Splicing, connection sketch. Cable to the light outlet above the table. 14.3 cable to the switch junction box at second entrance to kitchen. Cable from the panel board. Cable to the switch near the sink. Cable secured to a stud no more than 12 inches from the cable entry into the junction box. Spliced, connected, wires. Cable to the light outlet controlled by a single pole switch. Cable to another electrical outlet. Cable from the panel board or other power source. 14.3 cable to another 3-way switch, or 4-way if there are more than 2 switches. Remove the cable sheath. Group all ground wires, bare, and splice them using the wire nut. Insert the connection into the junction box, leaving the pigtail wire outside the junction box. Group the neutral, white, wires from all cables, splice them together with a wire nut, and insert the connection into the junction box. Group the hot, black, wires from the cable from the power source and from the cable to the other electrical outlet. Connect them together by adding 2 black pigtail wires with the same wire diameter and insert this connection into the junction box. Group 1 of the pigtail wires and the traveler wires, black and red, from the 14.3 cable to the another 3-way switch junction box. Group the other pigtail wire and the hot, black, wire from the cable to the light outlet controlled by single pole switch. Trim all wires to no shorter than 6 inches from the bottom of the junction box. Insert grouped wires into the junction box. Coil the ground wire and insert it into the junction box. Coiled ground wire. Wires for connection to a single pole switch. Wires for connection to a three-way switch. Splicing of. Light outlet junction box above the table with a cable from the switch, one cable. Splicing, connection sketch. Cable from the switch. Remove the cable sheath. Cut the wires to the desired length, not less than 6 inches. Insert the wires into the junction box. Temporarily cover the wires in the junction box with the supplied cover. Spliced, connected, wires. Splicing of. Single pole switch junction box with cable from the power source and cable to the light outlet, 2 cables. Splicing, connection sketch. Cable to the light outlet. Cable from the power source. Spliced, connected, wires. Strip cables jacket. Cables sheath, jacket, shall extend beyond enclosure, electrical box, entry not less than 1/4 inch. Separate ground, bare, wires from others and push ground wires towards the back of the box. Twist ground wires, hold by fist, it gives you 6 inches minimum length of wires from box entry, required. Keep longest wire as pigtail and cut shorter wires by fist. Thread long wire through green wire nut hole and twist it clockwise. Fold and push spliced ground wires with connector neatly into the box, leaving pigtail from wire nut outside the box. Push all wires into the box, hold them in place. Catch all wires and cut it in the front of the fist. Strip ends of neutral, white wires about 1/2 inch. Splice neutral, white wires, twisting it by pliers and wire nut clockwise. Fold neutral, white wires and push neatly into the box. Fold remaining wires and push neatly into the box. Splicing of. Light outlet junction box above the sink with a cable from the switch, 1 cable. Splicing, connection sketch. Cable from the switch. Spliced, connected, wires. Remove the cable sheath. Wrap the ground wire, bare, around the grounding screw and tighten the screw. Trim the wires, no shorter than 6 inches from the bottom of the junction box, required, and insert them into the junction box. Splicing of three-way switch junction box with a cable. 14. 3. Enabling control of the light outlet from the second switch box and a cable to the recessed light outlet housing junction box. 2 cables. Splicing connection sketch. Cable to the recessed light outlet. Cable to provide three-way control from other location. 14. 3. Spliced connected wires. Strip cables jacket. Cables sheath, jacket, shall extend beyond enclosure, electrical box, entry not less than 1/4 inch. Separate ground, bare, wires from others and push ground wires towards the back of the box. Twist ground wires, hold by fist, it gives you 6 inches minimum length of wires from box entry, required. Keep longer wire as pigtail and cut shorter wire by fist. Tread long wire through green wire nut hole and twist it clockwise. Fold and push spliced ground wires with connector neatly into the box, leaving pigtail from wire nut outside the box. Separate neutral, white wires from other wires. Fold and push towards back of the box, hold it in place, catch and cut it in front of the fist. Strip ends of white wires about 1/2 inch. Splice white wires, twisting it by pliers and wire nut clockwise. Fold spliced white wires and push neatly into the box. Fold and push remaining wires towards back of the box, catch it and cut by front of the fist. Fold wires and push neatly into the box. Splicing of recessed light fixture with a cable from a switch or other light fixture and a cable to the next light fixture. 2 cables. Splicing connection sketch. Cable from the switch or recessed light. Cable to another recessed light fixture. Wires of the light fixture housing junction box. Bare or green, ground wire. White, neutral wire. Black, hot wire. Spliced, connected, wires. Strip cables jacket about 6 inches and strip ends of wires about 1/2 inch. Open the junction box and junction box rectangular knockouts for NM cables. Insert cables into opened knockouts. Connect ground, bare wires from the cables to quick connector of green, ground wire from light fixture. Connect neutral, white wires from the cables to quick connector of the white wire, neutral from light fixture. Connect hot, black wires from the cables to quick connector of the black, hot wire from the light fixture. Close junction box cover. Slide fixture to desired location and tight the screw to lock position of the housing. Splicing of recessed light fixture with a cable from a switch or other light fixture, 1 cable. Splicing, connection sketch. Cable from the switch or recessed light. Spliced, connected, wires. Strip about 6 inches of the cable sheath and strip the ends of the wires about 1/2 inch. Open the junction box of the light fixture housing and open the cable knockout in this junction box. Insert the cable into the cable knockout and connect the light fixture as follows. Ground, bare, wire from the cable to the ground, green wire connector of the light fixture. Hot, black wire from the cable to the hot, black wire connector of the light fixture. Neutral, white wire from the cable to the neutral, white wire connector of the light fixture. Insert the connected wires into the light fixture junction box and close the junction box cover. If you don't know the exact location of the recessed light, you can leave the cable behind the drywall between the joists, and the remodel type recessed light, with can or canless, will be installed after the ceiling is finished. Cable for a remodel type recessed light left behind the ceiling. Kitchen wiring junction boxes spliced and ready for rough-in inspection.